Hello, I'm Eric Snodgrass, and thank you for watching today's long-range forecast video brought to you by Nutrien Ag Solutions. This analysis is being provided for perspective only, and any decision made based upon this presentation is the sole responsibility of the person making the decision. Finally, please remember that all long-range weather forecasting is speculative by nature. Well, I want to begin with this map. I've been working on this for the last couple of weeks, trying to understand some of the major stresses we've seen across the United States in terms of weather stresses for this growing season. So what you're looking at here is a cumulative solar flux map that begins back on the 15th of May and goes through the 10th of October. And I stopped it around the 10th of October because through a big section of the central part of the United States and out in the Northwest, this is when we got our first frost event coming through. Now, when you look at this overall, I want you to see the flow pattern that we saw throughout much of this growing season. Remember, we had seen quite a big southeastern ridge that returned multiple times, and so that's clearing out the skies, allowing for much above average solar light, sunlight coming in throughout the year. We know that we did transition middle of the season to a ridge that sat over this region, which is why we picked up quite a bit of additional solar flux in that corridor. And there was for a while a region right in through here where we were getting a very dry pattern, which featured quite a bit of sunshine and quite a bit of heat. But in all three of those situations, we continued to pound this particular part of the United States with not only a lot of additional precipitation, but a lot of cloud cover and cooler weather. So when we break this all down and look at it on the whole here, but the only places across the United States that weren't majorly anomalous throughout the heart of the growing season, not the end of it, but the heart of it, was going to be the west coast of the United States. Now, we do understand what happened in the Pacific Northwest toward the end of the season with the cold weather that came in and the untimely rain, but that has been the region in the U.S. that saw the least difference from normal. So that's just another perspective on that. But coming back to this section of the United States, just take a look at this map. We're looking over the last 60 days at the departure from normal in terms of precipitation. And when you see in parts of the Dakotas that were off my charts here, that's 10 inches of surplus in terms of precipitation. And this covers a wide section here of the United States with incredibly heavy rainfall. It's not as though we didn't get heavy rainfall outside of that. Like we just said, some very wet conditions coming into parts of the Northwest, and at times we've parked fronts here across the Southeast, locally relieving drought. But the focus has primarily been on a storm track that's run through the middle part of the country. So add that to the snow that we'd already seen in this area. This is just your seasonal snowfall accumulation here. We have a big section that's seen 1 to 3 feet right in through here. This has been a region in the United States that has just had one of the toughest growing seasons in quite some time. Now, that snow has melted for the most part. This is looking at the snow water equivalent through midnight today. And we can see that most of it has melted away. And I did notice that when you saw the big cyclone that kind of went past the other day, that we were noticing the clearing on the backside and weren't seeing any snow on the ground in through that corridor. So the snow did melt on some of the warmer conditions, but that's increased the flooding problems that we've had in the area. And the fields are saturated, they're mucky, and they're muddy, and therefore not a lot of field work is happening in the north central part of the United States. We can add to that this map. This is looking at yesterday around midday. Around that big low pressure system, we had sustained 20 to 40 mile an hour winds sweeping through this corridor. So we are really adding up the stresses in this area as we finish this growing season, and it's adding to a very rough growing season up to this particular point. So I just wanted to bring you up to speed on some of these more recent things. Now look at what this has done in terms of soil moisture availability. So we're looking here at the top 3 feet of the atmosphere, and this is in percent. Top 3 feet of the soil, and this is in percent. And you can kind of pick out those regions that are extremely wet and those regions that are extremely dry right now. And last week when I was producing the long-range forecast, I showed you this map, which was the calculated soil moisture anomaly map. So this is a more important map to look at because this is just the values. This is what it looks like compared to normal. And what was amazing was with the system Nestor that went through here, plus the lingering boundary that sat in this region, bringing in quite a bit of rainfall before Tropical Storm Nestor, look at the changes here. So we have changed the soil moisture values here, especially across parts of the southeast as of late, while much of this wedge in through here is not seeing too much of a change at all. It's just continued to be quite wet. So we've added this over the last 7 days. So this is your 7-day precipitation map, and we have seen a bit of a pattern change. At least we've gotten rid of that huge ridge over the southeast and have brought systems a bit farther to the south in storm track, and we have been able to get more precipitation over the southeast. So some locations are just in the last week picking up several inches of rainfall. Yes, it's good for drought, but it's also a time period where we need to be in the fields and harvest. So it has been an impact on harvest efforts. Well, if you've been watching our content this week, we've been talking about this major model discrepancy that's been going on between the GFS, which I have over here on the left, and the European, which I have over here on the right. And much of that discrepancy was due to the timing and placement of a cutoff low that was sweeping through the four corner states and merging into the southern plains. Well, I just want to let you know, in the overnight model runs, the GFS has finally come back into alignment with what the European model is saying. There are still differences. The GFS tries to keep this wave a bit more open. I'll show it to you in a few moments, but at least it's no longer a complete opposite run from what the European was saying. So you can pause this and take a look at some of the local differences in your area, but from a broad macro scale view, the agreement is much, much, much better. Just to let you know, we have other models we can put into the mix as well. This is the model from Canada called the GEM, and this one over here is from Germany called ICON. And we can see that those models are also in agreement with what we're seeing from the European and now the GFS. And the maps you've been looking at here are only over the next 5 days, so they take you through Sunday evening in terms of total accumulated precipitation. So I just would like to show you what the problem has been. The European model has been a bit more reserved in the flow pattern. It's had features that have been a bit more highly amplified, and also this little cutoff low right here has been a major disruption in the flow of the atmosphere. So this is where the European model wants to put this by 7 p.m. on Saturday, and this is what the GFS is doing. If I go back and forth, you can kind of see the differences here. Notice that the GFS is a bit more aggressive with this trough. It has an open wave that's here, which means this whole thing tends to move much quicker to the east, and if the wave is open, it doesn't tend to draw more moisture. Well, if a wave is cut off, it means it's sitting here and spinning like this, meaning it has the ability to wrap more moisture into the midsection of the country because of its cutoff nature. It's also slower. So that is the big difference between the two models as we get through the end of this week. Now, these model differences carry into week number 2 as well. I've got you now to next Wednesday. Both of these images here, GFS is again on the left, the European is on the right. And look at this. The European model is trying to yank this low pressure system out such that in the day on Wednesday through Wednesday evening, it's now building a deep low over Michigan. The GFS has nothing to do with it. It's a much more progressive pattern. It has brought this ridge that's in the European model much farther to the east, much quicker. And as a result, the GFS midweek has nothing in terms of precipitation, and the European has a large storm system soaking a big section of the country right in through here. Now, what did we see most recently? The GFS came back into alignment with what the European model said, what the German model said, and what the Canadian model said, which means at this point, my tendency is to trust the other 3 models and maybe think that the GFS is not on the right idea. Maybe it's some sort of initialization problem right now with the GFS. I don't know. But I'm going to say at this point, we need to be watching midweek next week because I think the European actually has a handle on this pattern. And this is it. You see, the GFS brings this ridge into the western United States onshore here and keeps this deeper trough progressing farther to the east quicker than what the European does. Now notice this, the European model keeps that ridge in this place. It keeps the main trough swept back a bit further, much more positive tilt here, and even has a secondary piece down here, and these all combine and sweep through the mid part of the country. Now what does all that do? Well, that creates that big low pressure system in this area. It keeps the southeast much warmer as we progress toward the end of the month, and these model differences, where they may seem subtle to a casual observer, they're enormous. when it comes to the timing of precipitation systems next week. But they do both feature some sort of ridging here and ridging over Greenland. And also, this negative North Atlantic oscillation pattern really well defined in both models, although the positions are off. So again, this is just looking out into the beginning of next week. So when we put that week 2 pattern together, look at what the GFS is saying versus what the European model is saying only for week 2. The European is much wetter in this corridor, whereas the GFS with its more progressive pattern is keeping the wetter conditions offshore and bringing on a lot drier weather here. Now, I would imagine that most of you are rooting on the GFS model with this pattern, and I get it. I understand why. But I hate to say that I think the European actually has the pattern, better locked down. And it doesn't just stop here. We can look at temperatures now. With the more progressive GFS, look at what happens by the time we get out to the 29th. It wants to sweep in the colder air much faster than the European model does. And so you can see here, if you're over the southeast, it's still sticking around warm through the 29th and maybe even into the 30th, whereas the GFS wants to crank those temperatures down quickly and rebuild the heat back out west. And the European model is just much more reserved with this. So it's about the progression of the pattern, the European being slower, the GFS being more amplified and much quicker. Now look at how this pushes out through the month of November. So this is a long-range forecast. We better get to that. What you're now looking at was just released yesterday. We're looking at the European weekly forecast, but this is an entire month worth of precipitation anomalies. Now, with this pattern, we are seeing drier in the Pacific Northwest, drier in the Canadian prairies, and drier in the north central part of the United States. And I am very happy about seeing that in this area. But you notice that the model's painting this region quite wet. It's also keeping the warm bias here with the cooler air tucked back into this area. Okay, I need to know what would make that happen. Do our current global wind patterns and ocean temperature patterns match this? Because the CFS model wants to paint almost the entirety of the United States dry, with the exception of the Northwest. It wants to take all this moisture and shove it offshore, keeping with that more progressive pattern from the models run in the United States. It's the same theme. So let me show you why I think the European model has a handle on this. Now, I am not giving this to you with an abundant amount of confidence. I'm just telling you I'm trying to understand it. This is what I see. As we get out into the first week of the month, the European ensemble wants to keep a very strong Pacific jet. It wants to build it into what looks to be a bit of a high over low pattern here across the west coast of the United States. That is allowing for a much stronger branch coming from what's called our subtropical jet stream to work into this, digging out a trough here. That keeps this whole area much more active with weather systems moving forward, okay? So when I start to see that, I want to understand, is it an alignment with persistence? Is it an alignment with climatology that the southeastern part of the United States has this chance? And that's not just the southeast, it's the southeast, it's the mid-south, it's into the eastern corn belt, it is into the northeast. That whole region, are we going to be seeing wetter conditions? Well, looking at climatology over the southeast region, which covers basically from the Mississippi River to the Ohio River and everything toward the south and east of it, we've actually increased, look at the trend line, we've increased November precipitation by about 16% going back over the last 70 years or so. So we are actually trending wetter during this time period in that area. And by the way, don't think I'm just focusing on the southeast, because the southeast forecast here actually pertains to everyone else in the United States as well. So I went and found off of this map what were the 10 wettest time periods in the southeast region. And those years are right down here. Now notice this. The map you're looking at is 200 millibars, so jet stream level, zonal winds. Where you see the red colors is where we tend to have a faster jet stream wind. And notice this. You can see those faster winds in that same corridor that the ECMWF was painting it, which means a stronger subtropical jet stream was a common feature in these wet Novembers looking back historically. That's our first clue. In other words, the models are lining up with the analog approach to this as well. What about the 500 millibar pattern? Well, in those wet years for the southeast, we tended to have a trough here in the Gulf, in the Bering Sea. We tended to have a ridge that ran up here into the Gulf of Alaska, a trough that was sitting somewhere, centered in the middle part of the United States, and a ridge that was sitting here with a deeper trough that was south of Greenland. Well, what's the forecast for the month of November? That's what's shown to you over here. Well, we see in this area a trough sitting here with a ridge building up somewhere in the Gulf of Alaska. There is broader troughing in this area with a ridge that's here. And we don't necessarily see troughing in this particular quarter, so that's a little bit off, but there are some similarities. Things are lining up, which means that these years are looking very similar to what we've got here. And I'm basically trying to understand, do the models have it right? Look over here on the map on the left with me. Do they have it right that this corridor is going to be active? That's the question we're trying to answer. So then I wanted to know, are our current teleconnections, the current global wind patterns and ocean patterns, matching up with this? So look at the images on the right first. We do have warm water that extends into this area. We do still have some cooler water that is over here. And we notice the cooler patch of water here associated with our Indian Ocean dipole event, shoving the warm water onto this side of the Indian Ocean. Now, the Indian Ocean dipole recently kind of hit a peak and has started to come down a little bit. And that's why I've started to see some cooling. I'll put a C of it over here, and some warming of the ocean temperatures there recently. It's still a strong response in the atmosphere, but it's slackened a little bit. Now, up until this point, we have pushed some warmer water back into this corridor, which is why we've seen this increase in Niño region 3.4 of ocean temperatures. And again, that region is right over here. What this has also done is recently we've seen some pockets of warmer water trying to show up here, intermixed with our cooler water over by South America. Now, why would I tell you all of this? When you look at this, we still have a strong Indian Ocean dipole event, okay? But we've seen some warming of the ocean waters in the middle, which looks kind of like El Nino, yet it's not anchored to South America. It's more of that Molokai El Nino event. Now, I'm bringing this up because those same wet Novembers had, for the most part, really, really warm temperatures in the El Nino region. And we don't have that right now. But they did also have cool water here, warm water here. We do have that right now. They also had warm water in this area with cooler back here. We have that right now. So my question is, even though we don't have the warm water here off of the west coast of South America, is the atmosphere still behaving as if there is an El Nino? Because that is definitely an El Nino signature. So I went and looked here. During those years, remember, our wet years over the southeast, our 850 millibar zonal wind component was such that we would tend to produce an anomalously easterly wind there and anomalously westerly winds here. That makes sense with this particular flow pattern, descending air right in the middle of this, okay? Now, knowing that, I went to here. Since September 21st all the way to October 21st, we have had this. Very similar to those years that I just showed you, or wet years. It's the same thing that has been shown to you for a while on these Hofmüller diagrams I've been showing. Same exact thing, okay? So thinking about that, when there is El Nino conditions, we get that flow pattern. So even though the ocean temperatures aren't responding as if there's a strong El Nino, the atmosphere is actually behaving as if there kind of was one. So you're asking, okay, Snodgrass, where are you taking all of this? I'm taking it here. You see, during those years that we had wet Novembers over the southeast, we tended to be dry in this corridor, wet here. We tended to be wet here, wet there, and wet in through this area. The European model, looking out over the next month, well, look, it has drier conditions sitting in through here with wet on this side. It's wet in through here, and one difference is wet also in that area. That was not common in those really wet years, but it was wet over here and wet in through that area. So I'm basically building a case to say I can make sense out of what the European long range is suggesting for the month of November. and it appears to be following this precipitation pattern. And that is one where we are going to be drier along the west coast of the United States compared to average. Doesn't mean it's going to be dry. They still get precipitation. It's the start of the wet season. Looks to be slightly drier than normal in the north central part of the United States and potentially in the Canadian prairies. Again, that doesn't mean we won't get clipper systems that move through that occasionally bring in precipitation, but maybe on the whole, when we look at this at the end of November, it might show up with a slighter, drier bias. And I am praying that this model is right for those folks up there in the Dakotas. And even though our drought situation, relieving it will be fantastic over the southeast, remember, we are still trying to harvest crops in this area, so that could be interesting to see how that plays out. Also, as I finish this up, take a look at South America's precipitation patterns through the month of November. That is a key piece to all of this and something we'll be addressing in tomorrow's video as well. All right? I hope that made some sense and is useful to you, but I'll go ahead and wrap it up right here. Thank you for watching. Have a great week, and I'll talk to you again tomorrow. Thank you.